Good afternoon, everyone. My name is Takemura. I'm so pleased and honored to be here to present our Tangible Earth at this Global Philanthropy Forum and to talk about the global perspective provided through our globe. Our world is so globalized, and everybody said we need to think globally. But we don't have the global media in the real sense, the global media which visualize what is really going on our planet, and the global media which enables us to think globally. And I'm very sorry that still now, school children born in 21st century are learning geography, geology, and global environment using the two-dimensional map invented in 16th century, or using the conventional static globe, which never represents the exceptional beauty and dynamism of our planet. That is why we created this. This is the world's first interactive digital globe, interactive in the sense that you can spin it with your hand in any direction, but you can zoom in on the specific areas using the magnifying pointer function like this. In this case, I'm showing you some image of the Earth's surface seen from space, from the viewpoint of the space shuttle. So we are approaching to Himalaya glaciers, and if we move to the desert of Middle East, we will get this kind of image. And we move on to Sahara. And if we put on the day-night terminator, it's real time. And this globe represents the present situation of our planet. So you can see people in Japan is now greeting sunrise, and at the opposite side of the globe, you can see people in Brazil, maybe, is now enjoying sunset. And if we put on the real-time cloud data, the cloud data is updated every 1 hour through the internet from the satellite. And now we are showing you the animation of the cloud movement over the last 4 days. And when the animation stops, it will represent the present situation, present cloud distribution. So now animation is stopping, and it seems that the people in California is enjoying fine weather. Yeah. But please note that this cloud is swirling in this thin layer of the air. The layer of the air, the troposphere, is in real life about 10 kilometers thick up to the altitude where jets fly. But at this scale, it becomes less than 1 millimeter thick. So even children can see how fragile the layer of the air is. And this kind of the analog tactility is very important. And that is why we create this kind of the analog tactile globe rather than creating the 3D CG globe in the tablet or PC. Even children can see how fragile, and even the space shuttle is flying only 2 or 3 centimeters above. And you can see every miracle of life on Earth is happening in this thin layer of the 1 millimeters. So I will show you some other aspect of our living planet. It's serpentine ocean currents. At the opposite side of the globe, you can see the Gulf currents, which conveys lots of solar thermal energy to the northern Europe to make the climate of the northern Europe far milder than for the altitude. And you can see the sea surface temperature. You can see again the serpentine Kuroshio, the black currents, and it's visualizing the seasonal variation, seasonal change of the sea surface temperature. So it's just like the breathing of the Earth. And if we show some biodiversity contents, This is now the globe is showing the plankton blooming detected by the polar orbit satellite with the trace of humpback whales attracted by the planktons. So we don't know how they know it, but actually they know that their restaurant is around here in Arctic. And at the opposite side of the globe, you will see the very amazing birds. That couple of birds start migrating from the Arctic areas, and they go south separately, one along the African coast and one along the South American coast. But they encounter again somehow without using any GPS cell phone, asking to each other, where are you now, or something. But actually they encounter like this. Even researchers never know how they communicate to each other. And if we overlay the plankton again, you can see when they reach Antarctic, the restaurant is ready, and they start serving lots of. What is amazing here is that birds are amazing, of course, but what is also amazing that we are living in such an age that we can visualize the living dynamism of our planet in this way, in such a comprehensive way. So maybe we are the first generation in the human history who recognize the living dynamism of our planet. So why do we teach children using two-dimensional map? And we need to disseminate this kind of globe all around the world. And let's go back again to the topic of global perspective. Because we human society really needs a global perspective in various dimensions. Now I'm showing you the El Nino phenomenon, which brings about the abnormal weather all around the world. And I'm now showing you the typical El Nino phenomenon. The warm sea concentration, seawater concentration is found here, like this, at the east part of the Pacific. And you can see, well, normally the concentration of warm seawater will be found in the western part of Pacific due to the strong east trade winds. But in the phase of El Nino, it shifts to the east, and the eastern trade wind get weak, and it moves to the west, east, and it brings about the abnormal weather all around the world. One example here is it's based on the UN data. The flood events in Colombia, for example, correlates dramatically to the El Nino La Nina patterns. And also, normally the warm seawater concentrated in the Western Pacific brings lots of rainfall to the jungle, tropical rainforest in Indonesia. But at this case, they will suffer from the drought, Australian drought, and the extensive wildfire in Indonesia, and also the cold summer in Japan, or it correlates somehow with the El Nino phenomenon in Indian Ocean called dipole mode. So abnormal weather is correlated to each other. It's called the Atella Connection. So any local event should be recognized in the global context, in the context of the Atella Connection, global teleconnection of the climate variation like the El Nino. And now I'm showing you another example. This is the accumulation of the earthquake. Now here you can see the very earthquake-prone area in here, California, the San Andreas Fault. And at the opposite side of the Pacific plate, you can see the biggest concentration of seismic events, Japan, the cross-section of 4 tectonic plates. And I'm now replaying the March 11th event, the exceptional magnitude of earthquake you will see here on March 11th, like this. Yeah, how exceptional it is. And after devastating the Tohoku area, the tsunami rippled throughout the Pacific. This is a representation of the tsunami event. But point here is that the tsunami rippled throughout Pacific, throughout the world, not only as a physical tide, but also the socio-economic tide. Because the supply chain nowadays is globally interconnected. So, for example, Toyota reduced their car production not only in Japan, but also more than 50% in India, China, and the US due to the shortage of some parts which was supposed to be produced in the Tohoku area. And 6 months after March 11th, Japanese companies were severely hit again by the flooding in Thailand, as you know. So nowadays, the natural disaster is no longer a local event. You might be hit. Your company or your business, your life might be affected by the disaster at the opposite side of the globe. So we always need to have the global perspective. And I'm talking now about the global risk transfer. If we can find the global risk transfer in various aspects. For example, now I'm showing you the global circulation of the air pollutants. Blue represent sulfur dioxide, green nitrogen dioxide, yellow CO, and these are emitted from might be your country, but it circulates all around the world globally. So by looking at this kind of image of the air pollutant, hidden aspect of our planet, even children can see how we are connected to each other, sharing one globe. And if we look at the southern hemisphere, it seems that it's very clean, free from the pollution. But if we overlay some other layer, like ozone layer, you will find the ozone hole, even 25 years after the ban of the fronts. And so the ozone layer in the southern hemisphere is much affected by the from the emission from the northern hemisphere. So thus we are so connected to each other, sharing one globe. And if we talk about the ultimate global risk transfer, we can help talking about the increase of CO2 emission and global warming, climate change. Now I'm representing the CO2 concentration, seasonal variation, very famous zigzag patterns, and in these 20, 30 years, it increases much and it reaches about 400 ppm already. As you see here, the urban population increase, very rapid, skyrocketing urban population, especially after 1980s. The megacities, more than 10 millions, proliferating in Asian countries, and skyrocketing demand of the fossil fuels and the deforestation. it causes such a rapid increase of the CO2 concentration, and partly due to this anthropogenic cause, our global atmosphere, we affected much to our atmosphere. And the global warming is progressing, as you know. This is the simulation of the global warming in this century based on the A1B scenario of IPCC, emission scenario of IPCC. And if we stop around 2070, you can see the rapid temperature rise, especially at the Arctic areas and the Tibetan Himalaya areas, which is covered with the ice, which originally have the albedos, 90% of albedo, which reflect sunlight. But if they lose the ice albedo, they start absorbing 90% of the solar thermal energy, and the global warming process will be much accelerated, as you know. So, and if we overlay the polar orbit satellite data of about the diminishing sea ice in Arctic areas, it's so dramatic. And also, if we focus on the Himalaya areas, you can see such a drastic decrease of the glacier ice, and it leads to the scarce water in the downstream of the Yangtze rivers, or especially yellow rivers. Yellow rivers used to be like this, but nowadays we observe over the last 15 years the no-flow events. So the global warming leads to the water scarcity and the food crisis. Even children can understand this kind of effect. And also, if we look at the elevation of the coastal areas, the red zone represents the low elevation coastal zone, less than 10 meters of the above sea level. So you can see the in southern part of the Mekong's, Bangladesh, Thailand, Eastern Tokyo, London, New York, many megacities are located at the low elevation coastal zone, but especially in China, nearby, including Shanghai, Qingdao, Tianjin. This area includes more than 150 million people in low elevation coastal zone, which is very vulnerable to the sea level rise, flooding, liquidization, etc. So thus we are facing a big challenge. And this kind of simulation makes us pessimistic. But I think this simulation represents hope as well. We humans are tiny existence, just like, say, fleas on the back of a huge elephant. But this tiny fleas, start sensing and monitoring the subtle change in the body temperature and the physical condition of the host elephant, Earth, and naming it global warming and climate change, and start cope with it. And every day, now I'm representing the polar orbit satellite, and the data of the sea surface temperature sensed by the polar orbit satellite Shizuku, Japanese orbit satellite, and they are monitoring the very subtle change of the sea surface temperature, the body temperature of the elephant. And this kind of data is used for the prediction of the El Nino phenomenon, climate variation, and used for the preventing the the damage by the severe drought and flooding in the India, African countries, and Australia. And also there is as the panelists yesterday mentioned, the wildfire is damaging the forest rapidly, but this is the data of the wildfire sensed by observed by the orbit satellite. And this kind of the real-time data observation is disseminated to some countries like Brazil, and it is used for the preventing the illegal deforestation, for example. Thus, we have a lot of things to do, and anyway, in order to make our society sustainable, we need to be more creative. And we are the species which has been very creative and intelligent over the thousands of years. This is a replay of the hurricane. Typhoon Haiyan with the trace. And if we replay, so this kind of the typhoon monitoring will be provided on this globe in real time in this year. And also, I will show you the alternative simulation of the global warming. Alternative simulation represents the big change, big variation of the temperature rise. In the scenario in which we mitigate the temperature rise within 2 degrees, you can see the big change in the temperature rise, especially in the Himalayas and Tibetan areas. So this is an alternative simulation. We can visualize through this globe and simulation also the alternative future, our choice. There's another path to create a different future, to make a difference. So even agricultural revolution was the creative reaction to the climate change, as you know. In the Younger Dryas age, about 12,000 years ago. So to be sustainable, we can be creative. We should be creative, and we can be creative. So this is my message through Tangible Earth. And maybe this kind of image of the globe you have seen many times. Of course, this might be the first time you see our globe in this way, but the image of the globe, this kind of globe, might have been in your mind, or might have been in the mind of the Homo sapiens for the thousands of generations. So my work is to visualize what is already in your mind, and this is the essential part of the art and design. Thank you very much.